Good day, my fellow listener and my students. I'm here again with you in this class to take your physics. But before then, let me tell you again that my name is Adewale Johnson. I am your physics teacher. I always give you one assurance that each time you are with me in my lecture class, make sure you are with your Bible and your jotter. Write down any question that is confusing you, and you can always send it through that WhatsApp number that is shown on the screen, or the number directly, or through our email address. So with you in physics, I want to take the topic. I call it capacitors. I call it capacitors. 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 By definition, what do we call a capacitor? A capacitor is an electronic device. It is an electronic device used for storing charges. For storing charges. Electronic device used for storing charges. When two insulators, any two conductors separated by an insulating material is also a conductor. Is a conductor. I take you to some facts about this conductor. The types of conductor that we have. I want to have mica capacitor. I want to have a paper capacitor. I want us to have electrolytic capacitor. I want us to have parallel plate capacitor. More attention will be placed on the parallel plate capacitors. More attention based on parallel plate capacitors. More attention will be placed on parallel plate capacitors. More attention will be placed on this. These are two plates. Separated by the dielectric constant. This is between plate 1 and plate 2. This is my distance D. This is my plate 1. This is my plate 2. Between them is an insulator. Between them is an insulator. For a parallel plate capacitor, the capacitance of this capacitor, capacitors is directly proportional to the area between the plates. The area between the plates is directly proportional to the area between the plates. And is inversely proportional to the distance between the plates. Mathematically written. Capacitance, that is going to area. See the capacitance. Here is our area. Capacitance equal to distance. This is our distance. Let's bring these two together. Directly going to area equal to distance. I remove my constant. I bring my proportionality EOA over D. From the above, it shows that The capacitor vary directly with the area and inversely with the distance. According to that definition, the capacitor vary directly with the area and inversely to the distance from that equation. Now let's note all this. There's a question they asked in Y in 2000 and maybe 2006, 2014. They said list for the factors affecting the capacitor and capacitor. And that says take the effects. That's exactly what we want to do. The effect of area on the capacitance, distance, and the dielectric constants. The factors affecting capacitor and capacitor are factors affecting the capacitance of the capacitor. The capacitance of a capacitor. Capacitor are area of the plates, distance between the plates, distance between the plates, and the dielectric constants. Dielectric constants. Now let's see the variation mathematically by what we have seen. This is the factors, this is the effects. Factors affecting capacitor, this is effects. The first one is area. I just said the effect is mean the direct proportional value. An increase in area, increase the capacitance. An increase in area, increase the capacitance. And a decrease in area, decrease the capacitance. The distance vary inversely. So distance is another factor. An increase in distance between the plates, an increase in the distance between the plates decreases the capacitor and vice versa, decrease the capacitor. And a decrease between the distance between the and decrease between the distance increases the capacitor. Dielectric constants increases proportionally with the capacitance. These are the factors that affect the capacitor of a capacitance of a capacitor. Factors affecting the capacitor of a capacitor. That is one way. Yes. Let's look at how to charge and discharge a capacitor. Charging and discharging 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 a capacitor. And discharging of capacitors. Plus, minus between the plates. Plate A, plate B. Plate A here, plate B here. This capacitor is connected through a battery, plate A, plate B. How do we charge and discharge a capacitor? Consider a capacitor connected to a battery is said as the plates of the capacitor are connected to the EMF. Electron flows from the negative pole of the battery to the plate B, and electron flow from the plate A to the positive plate. This is negative pole of the battery, this is the positive. Negative pole, positive pole. Let me show you that. From the plate A to the positive plates. The EMF, that is, the EMF, the PD, between the plates increases. When the plate increases, the EMF will increase. Electron is flowing like this way, to this side, and from here also, back to this side. The EMF increases. V total, Q is normal. The 1 over C1 plus 1 over C2 plus 1 over C3.